Greetings once again, AP Calculus students. Mr. Record here from Avon High School, and we're going to continue to look at some problems from the 2022-23 Continental Mathematics League Calc Division. We're now looking meet to problem number 7. And as with all of the videos that I'm producing for these particular questions, I'm going to give you guys a general idea of how to set up the problem and then allow you guys to finish it out. So our problem number 7 says a cube is expanding so that its surface area is increasing at a constant rate of 12 times the square root of 2 square inches per second. We're asked how fast is the volume increasing at the instant the surface area is 192 square inches, and we want to include the units in our answer. So if you recall from a while back, especially if you're a student of mine that's watching this is going to be what's known as a related rate question, which is something that we tackled way back in unit number 4. And so if you remember, the way that I like to scaffold these problems is that I typically like us to draw a picture. Now, sometimes the picture is very poignant and it gives us a lot of great information. And sometimes the picture is kind of just a way just to get something written on paper. And then I always tell students to write down all the things that they are given. Write down what it is that you're trying to find. And then, of course, sometimes the hardest thing is to determine what is the equation. The given, the find, and the equation. All right, well, what is our picture? Well, our picture is a cube. A cube might look maybe something like this. That's about as cubical as I can get with my limited artistic ability. And it says that this cube is going to be expanding. And so in other words, it's like moving out in all directions, getting larger and larger. Okay? So about the only thing that we can glean from this picture of this cube is the fact that, well, a cube is a three-dimensional square prism, if you will, right? That consists of edges that are all the same. And so it seems logical that we would just give each edge the same value, and in this case, I'll just call that x. So what is it that we are given? Well, the given value in a related rate is always going to be let me see if I can highlight this just a little bit better here, guys. The given is always going to be a value that truly is a rate given in the question. All right, so in other words, we're going to be focusing in on this guy right here, this 12 root 2. And so we want to know, okay, that 12 root 2 is some kind of a rate, but it's a rate of what? And if we continue reading through the problem, it says that the surface area is what's changing by 12 root 2. And if you kind of look into the context clues a little bit, the idea of the units there in square inches will tell us that no doubt that this is some kind of an area, and the per second just confirms the fact that it's a rate. And so what I'm going to have to do is use another variable that I'm going to call A for surface area. And so the derivative of the surface area A with respect to time is going to be this 12 times the square root of 2. And so we'll kind of file that away, and we keep reading, and it asks for us to figure out how fast is the volume increasing. Well, that seems pretty logical. We're going to find the derivative of the volume with respect to t. And we're going to find that specifically at the instant that the surface area is 192. So let's say we're going to find dv dt when specifically the A is 192. Okay, now this is a little bit more complex than some of our more run-of-the-mill how fast is the volume changing problems, because we have this connection to the surface area as well. And so the equation that we're going to look at might involve more than one. And so in that particular instance, we've got the idea of the surface area and the idea of the volume. But let's go ahead and list what those two formulas are going to be separately and see if we can come up with some strategy here. So the surface area of a cube, if you think about that, it's like basically how much space there is around, say, a six-sided dice. So you've got six sides, as I said before, each of which has the same amount of area, x by x. And again, if you have six of those, you're going to have an area of 6x squared. Now for the volume of a cube, this would be a formula that likely you would have to know even on the AP exam. Even though it's a three-dimensional volume, it's one that doesn't involve pi. And so the volume of a cube is just side times side times side, or in this case, side cube, x cubed. Now, yes, we could go ahead and take the derivative of this volume with respect to t using implicit differentiation. So dv dt would be 3x squared dx dt. Remember, that's a technique of integration that you have to use whenever you're taking the derivative with respect to a variable, t in this case, as with all related rate problems, t that's not present within the problem itself. So we tack on the dv dt. Technically, we have 1 times dv dt, and then the 3x squared is sort of the normal derivative times the dx dt. But we have a problem. While we can figure out the fact that the dv dt is this expression, we don't know either the x squared value or the dx dt value. But if we hop on over to this derivative or this area of the surface area of the cube formula, we could take its derivative, and upon doing so, dA dt equaling 12x dx dt, now we have some very useful information. We're going to know this value of dA dt. That's given to us in the problem. Now, that alone is not enough for us to be able to solve for both the x and the dx dt. But you have one other little clue in this problem. The fact that the surface area is a certain value is going to enable you to figure out a specific x for which that's going to be true. And then it's sort of like dominoes falling. Once you find the x, you've got the dx dt, and then you should be able to come up with the ddt. I hope this helps. Good luck finishing it up, and be sure to check out some more of the Continental Math League help videos.